Hello there. In this video, I'll show you how to do growth accounting using a cobb-douglass production function and data from British Industrial Revolution period. So we'll look at years between 1760 up until 1869. This is data from historical sources on output, that's Y, labor, L, capital stock K, energy consumption E, and shares of or income shares of labor, capital, and energy in output. So we will need this data for the further analysis. Now, as you can see, I converted the time series data into index numbers just for the sake of making the analysis easier. So with the index data, it's easier to analyze the time trends and divergence. So let me show you a quick snapshot of what the data looks like. So I'm gonna highlight the whole column. So these first 5 columns, go to insert and line graph. Alright, it does look like my Excel is treating the treating this first data as a data point instead of an x-axis. So while I do this, I will now actually manually create a graph. So that's that. And as you can see, that's what it is doing. So I need to delete this. Here it is. Now it looks like okay. Now I still have these covered here. So I'll have to delete them as well. I should have done it manually. Anyway, that's done now. So the only thing here is we don't have the year, so I can actually show how to do that as well in case you don't know, and I don't believe that you don't know. If you're interested in doing growth accounting in Excel, I'm sure you are good at Excel as well then. So here it is. So we've got the data, and as you can see, the data is trending upwards in the later years. And I should also say that I will discuss what the growth accounting method does and why we need it in any case. If you're attending my lectures, you will learn about it in the lectures. Now, as you can see, this is the first line here. The top line here is the blue line is energy. It's actually growing exponentially in this period here. It's a linear trend and then huge growth rate change here and then a constant rate. And then you have this yellow, brownish yellow line, that's capital stock, with the brown, darker brown line Y. So it looks like much of, the trend in the there's a lockstep change, I would say, in the trend growth of capital and labor, capital stock and income, or GDP. And this gray line is here, is basically labor. So it's growing but at a slower rate. Much of the change and much of the uplift here is due to, most likely due to, in the income is due to the energy, because energy is growing faster than anything else. So that makes sense, right? As the economy was industrializing in the 18th and early 19th century, the machines, large factories, required huge amounts of energy, and that explains why we have faster growth in energy than the other factors of production. Now, the purpose of the accounting exercise and growth accounting exercise, so I'm going to delete this now. We've seen which looks, trend of overall long run trend of this data. Now the purpose of this exercise is to understand which of these 3 factors, labor, capital, and energy, contributes more to the growth of output during the Industrial Revolution, or contributed during the Industrial Revolution period. Now, this is actually data from historical sources, so it's a reliable data and it's not a made-up data. For your homework, you could actually do as exercise on the contemporary data if you would like to practice. Sorry. Now we will be assuming that the output Y is produced combining capital, labor, and energy in a cobb-douglass form, multiplicative cobb-douglass form here, LKE, with A being the total factor productivity, or what we call as economists technological progress that is not part of growth in LKE. It's an technological progress or innovations that are making our utilization of resources more effective, or we efficiently utilize LKE altogether here in this case. Now alphas, betas and gamma exponents are usually what we call this elasticity of factors with respect to I should say elasticity of output with respect to factors, and they also indicate the relative importance of each factor. For example, alpha, the higher this alpha, the more important the L is to the growth of output, or higher the beta, the higher the importance of the capital in the growth of output, and the same with gamma as well. Now there is a bit of transformation process here behind this lecture. I should say not behind it, there is between this function and this function. I made a huge leap forward here, and we will discuss this in seminar class about how you convert this level production function to a growth rate production function, or growth accounting equation, as you can see here. So nothing changed here except that there is this, we now express the percentage change in y, the output, as this weighted sum of the factors growth plus the percentage change in A, which is what I call this innovations or technological progress. And because this is a single A augmenting everything here, all the factors of production, we call this total factor productivity. Now, as you can see, this weighted because alpha, the share of factor income, labor income in the total output, is basically a fraction of that income paid to factor owners. So this change in factors, percentage change in factors, are then weighted. So these are the weighted, and you can also think of it weighted sum of these factor growth rates. Now we will now use this formula equation to calculate the or estimate the importance or growth importance of each of these factors of production in the growth of output. Now I'll just have to answer a phone call here quickly, so I'll pause here for a minute. Right, sorry, I'm back now. Okay, so we were looking at this formula. Okay, so we'll now implement this or use this equation in Excel spreadsheet here to calculate our oh, that's too much. So to do an exercise that disappeared for some reason. Okay, maybe we don't actually need it, so let's gonna go back to where we were. Okay, we actually don't need it. We can go back to this page whenever we want. So as you can see, what we need here is to calculate the growth rates of each variable here, and then average values for each of these alpha and gamma and others. Yeah. Okay, so here let's go ahead now. Right. So first thing is to get the growth rates for each period. So I split the long data here into 3 periods. It's arbitrary, but at the same time it's also something that economic historians have previously the periods that have been previously calculated or computed, or I should say looked at in the past. So economic historians think that the first industrial revolution, or the onset of industrial revolution, was in and around 1760s, and that ended around 1870s. And then beyond that period was the second industrial revolution. But there is also some disagreement on this issue, because some economic historians think that first industrial revolution was between 1770 and 1840. So there's always this non-consensus between economic historians. But we'll just follow the general consensus here, that not general consensus, but more or less almost all accounting growth accounting exercises were conducted on these 3 periods. Okay, so first thing is first. So we'll do calculate the growth rate of y, growth rate of g next, and growth rate of k. Oh, all so I'm going to change this to G, and growth rate of E now. As you can see, I don't have A here because we don't have the A at the moment. It's usually a residual or backed out in the calculations, so it's not observable. Usually innovations and science and technologies usually not observable. There's things that the methods that we use apply to increase as efficiency of our utilization of the resources. So let's go ahead with the calculation of our average growth rate for output for this first period. Now in this calculation we will be using what we call compounded annual growth rate method, or you can also calculate the growth rates using the level rate and then take the average as well if you want, annual growth rates, but generally economists usually use the compounded annual growth rates. So what it is this, so equal, open a bracket. Now in this period, the beginning of the period is 1760 and the end of the period is 1799. So we go to 1799, scroll down to 1799, it's right here, so this value here. As you can see, the income between 1760 and 1799 grew by a factor of 1.5 or 1.51, let's say here, yeah. So that's the growth in income, and we divide that end figure by the beginning figure, which is 1760, right? Close the bracket, and we need to raise to the power of this, whatever figure comes out of that, the 1 over the number of years in this first period. The number of years in this first period is 40 years. Yes, it's 40 years, as you can see. So 41 here is this period, is this year, because 40, we have the first line here, or first row, labeling, having the labels. That's why we are in this 41st row here. So it's 40 years in other words, yeah. So we can type 40, or we can also ask Excel to do the calculation for us. So I could use the count function in this range, for example. It just counts this number of cells here and gives us the result in as the cell quantity of cells, number of cells. So that's it. So it function counts the cells between, including B2 and B41, and then we close the bracket twice. Now this would give us the growth factor, but we take away 1 so that we get a growth rate then, yeah. So that's the formula. You can have a look here. I may as well show you in writing in a minute, but let's see what comes out of it. Right, so that's about 1.05% annual growth. So this formula gives us year-on-year growth rate. Now let's show you quickly how this, in writing, how this looks like. I mean the formula. So it's one note that I use to jot down my functions and formulas here. Right, so here it is. So growth rate of a variable is basically the, let's say it's output. So output in the end period, say 1799 here. So output in 1799 over output 1700 to the power here. So we raise to the power 1 over, so the number of years here is 40, and take away 1. So if I were to just calculate this part, this would give me the factor by which the income or GDP rose by 1799. But then we are interested in growth rates, so we take away 1. So what happens is that, if you remember, this was 1.5 and this GDP here was 1, and basically this would result in something like 1.0105, yeah. So this is a factor by which basically income rose, let's say, yeah. After we took the root power of 40, but we are basically interested in this part of the result, which is the growth rate part. So we then take away 1 to get rid of this. Right, so that gives us 0.0105, which is, I believe, is the same result as we have here. Where is it? Here it is, yeah. So that's that. So I can actually, if I want to, convert that into percentage as well. If I just click here, percentage mark, and to a 2 decimal place if I want to get it to decimals or percentages. But then I want it to be to give us a more precise result. So I'll extend the decimals to 3 decimal points, yeah. So that's it, or 4 here. Now so this formula is now calculating the growth rate. So if this formula is embedded in this cell now what I can do is, instead of doing each one of the remaining growth rates separately, I will just drag and drop the formula into each cell. As you can see, it calculates automatically the rates of growth for any remaining variables for the same period. So I double click here. As you can see, this cell is feeding the information in this column between the selected period or selected years. So now these are the growth rates for the variables. Now for the second period, I'll have to do manually again similar exercise. So open a bracket. Now the beginning period is 1800 and end period is 1829. So I'll go down to 1829. Here it is, divided by beginning period, first year of that period. So that's that, and then raise this to square power of 1 over so this is 1 over count the area period range here. So should give us 30 years here. So close the bracket and bracket one more time, because there are 2 brackets. So this first bracket closes this bracket, second bracket closes that bracket here, and as usual take away 1. Hit enter now. As you can see, again the same can be applied here, right? So highlight and apply the formula to other remaining cells, and we will be doing the same thing on this cell as well, but this time again the cell range changes. So it's 1830 to 1869, so we go right to the bottom, 69 over 1830, and to the power 1 over, okay, that needs to be in bracket just in case, 1 over count function, and highlight these. The range here should be 40 years if I'm not mistaken, so that's it, and we take away 1 again. Right, so the average annual growth rate, wow, it's 2% now. So this is the period where the growth of economy was higher. So output was higher. For some reason it didn't copy the percentage sign, so let's do a manual percentage sign and 4 decimal places and extend. Right, okay. As you can see, this tells you each period how the growth was. The growth in the earlier period, so before that, so in the last 40 years of 18th century was about on average 1%. Then the growth actually increased to in the first 30 years on average 1.5% annually, and the growth rate of output then actually was much higher in the latter period. That's last 40 years of this first industrial revolution, and then these are growth rates for each of these variables in these 3 periods. Yeah, and notice that of all these variables, growth rate of energy is the highest in each period. So next task is now to calculate in factor shares, and then we weigh all these growth rates by their importance. Yeah, growth rates of variables by their importance, or weights here that we can calculate in terms of income shares. Now this will apply only to these 3 variables, because income output growth rates will not be included in here. Now, so SI, or in this case it should really be SL, because that's share of labor income in factor in output, I should say. So basically what it means is the share of labor means the wages, total wages paid in this period on average, how much basically relative to the total output, yeah. And this value, well, let me calculate it first and then I'll explain what it is, yeah. So so these are alphas, betas and gammas here for each period. Now I should really have this as a constant value, but in each period you will see that the shares change, so we'll keep it changing for each period. So it will be then the average of shares, annual shares here for labor between the first period, so that's up to here, right? So close the bracket, hit enter, and we'll follow the same magic as before. So that's it. So we'll just express this as before, the in percentage terms. Now do the same thing here with my labor for that following period, 1800 to 1829. Here it is, hit enter. And so as you can see, share of income earned by workers didn't change much in the past, well, between these two periods. So and that means actually fairly fixed shares, and again here as well. And next we do now for the last period, so average between 1830 to the next. So there's a little bit of increase in the share, I think. Yeah, the 65, that's actually quite a large jump. So that means workers earned more in this period than before, yeah, in the previous period. So okay, so now let's see if capital owners earned. Yeah, they didn't actually, but the losers were the energy suppliers. So basically payments out of the income, out of total output or income, national income that British economy generated, about 60% went to labor or workers as wages, 22% went to capital owners, so as a rent, and energy providers earned about 18% of the total. So this should sum up to 1. Let's see. Sum and enter. Yeah, 100%. So that's it. So it should do the same thing. So basically, whatever the British economy generated as a GDP was distributed. Well, this is a theoretical assumption here, between laborers or the workers, capital owners, capitalists we call them, and energy suppliers. So biggest losers appears to be energy suppliers. Maybe they aren't necessarily, because energy supply may increase, but then the price of energy declines. So competitively supplied as a result will decline, because energy was quite competitively supplied. Coal mines in this period was popping up almost everywhere in the north of England. Now labor income increased, not because there were more labor providers or the workers, but there were also wage increases as well, in addition to extra workers joining the labor force. So the economy growing between this period basically meant that the wage income also increased. Capital income actually declined during this period, and wage income, energy income declined even more. So this much of the income generated was accrued towards compensating the wage income earners. Right. So now we will use these as weights to work out which of these variables were more important, relatively more important in generating growth or output growth. So it's basically, we call it contribution from each of these variables to the growth of income. Now we don't do anything with the income growth, so we'll just bring these values down here. So just move them down here and then change them to percentage again, right, just to make it much more easier to see working with percentages are better than, oh, okay, that's it, better than decimals. Now, so let's go back here to my original slide. So as you can see, so we want to work out the sum of these four terms, yeah. So growth rate of A, growth rate of L, growth rate of, so we've just done these parts, each one of these individually calculated. Well, we've just calculated beta and growth rates, yeah. So we just need to multiply them and sum them up. No, that's it. But we still don't know what the A is. This will be backed out in the process, yeah. So I'll show you what it is in a minute. So L, contribution from L is basically GL, I should say, is the growth rate of labor for that period times, so that's shift, where's my times, shift 8, the share of L in factor income in that period, hit enter. Ooh. How do we do that now? I did a huge change, so let's go back. Okay, that I didn't realize that I increased the decimal places by that much. Right, so the growth of output was 1.04% in that period, and contribution from labor was 0.36% touch points to this growth rate. Now, contribution from capital is then the growth rate of capital times the average share in that period. Hit enter. Ooh. Right, so let's see if I can copy the format of this into this. Yeah, I did manage to do that, and then we'll just now drag the rest here into this area. Right, so energy's growth contribution towards the output growth is relatively smaller than that of labor. Now notice that these three values add to the growth rate of output. Now what's left is now basically sum of these three. If I go back here, sum of these three variables, growth rates of these weighted variables, and also the technology progress should add up to the growth rate of income. So as you can see, what's left here is that we sum them up. What we get is about 0.8791%. Yeah. So what's left is now the remaining that's not explained by all these three variables of the growth, explaining the growth of output. So that will be dumped into A in a simple word. So that will be then why did I type 1? So this will be then that minus the sum of these three values. Yeah, hit enter. Right. Oh, so I'm gonna reduce this as well. I didn't realize that was also copying the format from before. So right. So now, just to prevent this happening again, right? Okay. So here in the first period, the greatest contributor to growth was the growth in labor. So more people joining the labor force increased the growth of total output in the end. So that's how we interpret that. Considerably less was coming from the growth of capital. Basically, capital accumulation was not fast enough at the time in this first period, and that makes sense because industrial revolution actually was much more advanced in the 19th century than in the 18th century. So that's just showing this result, and let's put this as growth as well, although it's from A usually that we're contributing towards Y, change in Y. So let's just put G here just for consistency, right? So, and then technological progress had its own share as well. Some innovations also contribute towards our growth in output as well. Now, can we drag and drop things? Like we can do this, yeah? All right, so let me just double check if I'm, yeah, so that's SL GL in the same. Okay, that's good. And I should be able to copy this form. Oh, no. Right, something is not right here, so let's do quick format copy. Right, so it's basically format is changing again. And yes, right. Now I can now calculate A as well. Right, so that's another one here. What went wrong? Right, percentage, yes, and right, negative. Okay, that's fine. Now it looks like in all periods, what's happening here is that the growth of GDP we observed is basically increasing, and the reason for this is basically one or two or all of these are also increasing in growth rates. In other words, the contribution from all the variables here that we consider is also contributing towards. So in the last period, 1830 to 1869, the growth rate of economy was on average was 2.32% per year, and towards this growth rate, labor contributed that much, growth in capital contributed that much, and growth in energy contribute that much, and growth in technological progress contribute that much. And notice this growth rate of contribution from energy is actually increasing, and in fact all of these are increasing, except that labor now is labor contribution is lower. That's because towards the early in the 18th century and beyond, the machines took over in the factories. Before that, the labor was important. As you can see, labor's growth was much higher here, especially contribution from labor was much higher in this period, but it just dropped a bit, and instead capital share now is growing. That's because more capital was accumulating in this period, more factories were popping up, more machines were being installed, and energy as such, because this capital requires energy to run, then the growth rate of contribution from the energy was also higher in this period. But above all, the technological progress was adding much more to the growth of our output, apparently in Britain. So this implies the innovations, the way we utilize the resources was much more important in the growth of our output, and that makes sense. This is something you will come across as well if you calculate as a homework your growth, if you do growth accounting exercise using contemporary data in Britain or USA. Now this is an interesting one, negative growth rate. That means technological progress wasn't good enough. Instead, the economy was being propelled by growth in labor, and most likely this is the case here, and then growth in energy consumption. So and then there was some technological progress, but in fact it's the case of all the innovations being in place or being used, and then most of machines were inefficient, so innovations were not good enough, basically, in other words. So that's why we have this negative growth rate. But in any case, these are tentative numbers usually, because in the historical context, calculating output with accuracy, especially for capital stock and output in general, is not that possible. So we take this as a tentative and indicative measures of contribution of variables towards growth in output. So this concludes our exercise here, and if you have any questions, you can ask me by commenting below or asking in the classroom during the lectures and seminars. As I said, in the seminar or classes, you will be learning how to move from this level output to growth equation. Yeah. For now, bye bye.